Hello and welcome to this Coolselector 2 update Q&A session. My name is John Broughton. I work for Danfoss, as you can see. Now, I have to say, first of all, due to unforeseen circumstances, we've got Norbert Blatz, who is taking the place of Morten today. And we are live broadcasting on YouTube, Facebook, 2 Twitter accounts, and also LinkedIn. So just to let you know, and we would welcome all your messages and questions for Norbert. Norbert, would you introduce yourself, please?
Yes, thank you, John. I'm Norbert Blatz, and I'm working for Danfoss since quite a while, 21 years or so. And I will try to guide you through the latest news of Coolselector we got into it. Yeah, well, this, just for your information, this live stream is happening across multiple channels and regions. So hopefully we'll get questions from all over the world. Finally, before I begin, the reason we are doing this live stream is to get all your questions. We really want to get your feedback on Coolselector. And so if you have any questions about Coolselector, don't hesitate. Write them into the chat, and we are glad to answer them. I will try to get back to this live stream as soon as possible. Yeah, well, so we can start. I'm ready to go.
Okay. Thanks, Norbert. And just to say hello, we've got people from Brazil joining. We've got people from Australia, so all parts of the world so far. Yeah, as Norbert said, we would really welcome your questions regarding Coolselector. Please tell us where you're from, what part of the refrigeration business you work in. Please, give us feedback, good or bad. That's always interesting to hear. So we've got people from Indonesia coming up, so that's good. So I think we have a question coming up in a second. Hopefully, okay, Portugal, Argentina, excellent. Indonesia, everywhere. Okay, so we have a question that hopefully will appear on the screen very shortly. There we go. So the question is, what is correct by Coolselector 80% load for an electronic expansion valve or an electric expansion valve selection, but AKV documentation is recommending a sizing factor of 1.6. So I'll hand over to Norbert, and Norbert can answer that for us, please, Norbert.
Thank you, John. So jumping directly into the details, that's great. Thanks for that question. In principle, the factor recommendation in the paperwork you can see is based on a similar aspect as we do in Coolselector. If you inverse the factor 1.1 to 2.1, for instance, then you get to the percentage value. In Coolselector, we decided to go to provide a default value of 80%, since this fits for many applications. But of course, it's up to you as a user and designer of a system to adjust that one to go for a valve that comes for, let's say, 50% load when it comes to low temperature application, where you need to have some pull down overcapacity.
Okay, thanks, Norbert. Okay, we've got lots of people joining in. We've got Mozambique, we've got Turkey, South Africa, Qatar, Denmark, Netherlands, Orlando, so Indonesia. Lots of people joining in everywhere, which is fantastic. So yeah, nice to see you all. So we've got a next question coming in, and that will appear on the screen. That's fantastic. So TXV results show the valve can be selected with a very low load of 30%. Is that by purpose, Norbert?
Well, this is somehow because of the principle of dealing with calculation results in Coolselector. Basically, you should always select a TXV at 100% load. So doing that, you get the best results and you're on the safe side not to run into a hunting system, for instance. The 30% is coming because we want to support also with the information about low load possibilities. So you may have a system that runs at low load down to 40%. The question is that still possible? Yes, it is. And this information is given by Coolselector. So in best case, you can go down to 25% even at part load, but not meant to select a valve basically on that load condition as a general rule. This we would not recommend.
Norbert, a question from me to you, actually, as we're talking about loading of an expansion valve. That's for a TXV. What about if we're talking about an EEV, an electronic expansion valve? What about the low load percentage of that one?
The low load percentage usually is about 10%. So depending on the valve design we have a variety of different types you can use as an electronic expansion device. It may vary, but it is around down to 10%. However, you need to consider that this value must not be much better than TXV, because you need to oversize an electronic valve, as mentioned in with the other question before. In respect to the TXV, don't select EXV at 100% load, but at least at 80% or 70%, depending on the need for the system. So if you set this in relation to the 10% lowest opening degree of the EXV, you may get a little bit different result in possible part load. But this is actually also information provided by Coolselector while entering your system condition, that this becomes part of the result displayed.
Thanks, Norbert. Very good. We have another question come in, which should be on the screen very shortly. It's the question. Hang on a second. Okay, that's from Mohammed. Is DRV a pressure independent valve? No.
Sorry, DRV?
Yeah, I'm a little confused also.
A discharge, maybe a discharge regulation valve.
Yeah, possibly.
Yeah,
possibly.
A discharge regulation valve, talking about an KVR, for instance, the KVR, KVP, and so on. This series is not independent to the ambient pressure, as it is spring-loaded, and the top part is not isolated from the ambient. Finally, so this is related to the ambient pressure, but the impact by varying the ambient pressure is almost nothing. An independent valve would be CPCE, hot gas bypass pressure regulating valve, for instance, that comes with an external pressure equalization connection, and this makes it isolated to the ambient.
Okay, thanks, Norbert. So the next question that should be coming up on the screen fairly shortly is, what is Coolselector?
Yes, thanks for that.
Good question.
I'll now come to that one. So let me share my screen with you. So the answer is, this is Coolselector. Coolselector actually is a tool that allows you to calculate and select all Danfoss components made for refrigeration and air conditioning. So that tool shall help you in a quite easy and straightforward way to get an answer on sizing and on performance, also for complex situations. We have designed this selection software in a way that you don't need to know the Danfoss component nomenclature. So it comes with the functionality of the different components. You can see here we talk about control regulating valves, electronic expansion valves, or stop shut-off valves, and so on. So this is a generic way to come into a dialogue and to find the entrance point to the component or to the functionality you are looking for. The same is for compressor condensing units, for electronic controls, and for sensors and switches. So I hope this clarifies a little bit what Coolselector is. It's a calculator that supports you in doing the right sizing and selection.
Thanks, Norbert. Okay, so we have another question come up, which is a fairly generic question. And the question reads, would like to know what factors are needed to consider to design an efficient cooling circuit for refrigeration. So quite a generalized sort of question, but Norbert, I guess you can also take that one.
Yes, in general, an efficient cooling circuit means that the temperature difference between condensation and evaporation should be considered as small as possible. However, this is given by the condition on site, basically. The next step is to have a good design for the heat exchangers, to have a small temperature difference on both sides, evaporator and condenser. So this allows a refrigeration system to come with the best possible efficiency. Of course, there are other aspects coming in too. That is the pipe work. You add control valves, you add to the circuit, that also, of course, impact. So if you size the pipes too small, you get a high pressure loss that increases your power consumption of the system. Also, if the control valves does not fit okay, this will bring your system in a bad condition, probably.
Thanks, Norbert. That's a perfect answer. Okay, so we're getting questions fast and furious coming in now, and we have the next question that's come in from Sogand, and it says, what is the allowable pressure drop across a control valve?
We provide maximum possible operating pressure drop or opening pressure drop of a valve in Coolselector. So this depends on the valve we talk about and the actuator used for it. So we have different types of valve. The most simplest one is a solenoid valve, a small one, EVR family, for instance. But you can also get it as an motorized valve designed for a very high pressure drop. So this depends, and you will find this information in Coolselector. While having the valve working, there are pressure drop possible up to a chocked flow condition, meaning like a hot gas bypass valve coming from the discharge to the low pressure side. But this information you can easily find also in Coolselector. We provide that there.
Thanks, Norbert. Just one sort of question to take on that discussion, Norbert, a little bit further. What would happen to a control valve then if you did not meet the required pressure drop for that valve to keep it open? Would it literally close, or would it be halfway?
This is an interesting question, and I have to refer or to add again. It depends on the valve type we talk about. There are valves that are not really designed for having a part load control. That is, for instance, a diaphragm, a servo-controlled solenoid valve. So the difference from having the minimum opening pressure drop to keep the valve just open and then let it fall close is quite small. So I wouldn't talk about a half open valve for such a design. When it comes to an ICS, a main valve that is designed for doing different opening degree, there you can get, of course, a half opening or quarter opening valve position. So if you use such a design as a solenoid valve, for instance, you have a quite wide range for part load condition, but it's designed for larger capacities at the same time. So,
okay, thanks, Norbert. Good answer. We have a question which we sort of answered in the preceding question, and the question basically reads, when it comes up on the screen, is, and I have difficulty pronouncing that Christian name, Bobayo. What is PD? A pressure drop ? So hopefully, yes, we've answered that in the preceding question. PD is stands for pressure drop within the system or across the control valve itself. So then we've got another question come up from Casper, and it says, to check the compressor condition, where can I find the discharge temperature? So over to you, Norbert.
Yeah. This I can show you here in Coolselector. If you go to compressors condensing units, opening the compressors calculation part, after entering condition and selecting the type you want to have, let's just pick up this SZ110-4 compressor. You can open up this information by a right click here in the headline, go to manage columns, and you find it in the list. Put a tick mark to T discharge, say OK, and it's added. So this value is an estimated value based on the power consumption, the running conditions, and some other details from the compressor. And this is the value you can refer to. You have it also if you go to performance details below of the result table. And here you get compressor discharge temperature, and here again estimated. So it's around 61.6 degrees Celsius in this case.
Thanks, Norbert. Okay, so next question has come in from Mohammed, and it says, what is the difference between a double regulating valve and a constant flow regulating valve? Again, Norbert.
A double regulating valve. Can you help out? Do you know that? I'm not sure what is meant with a double regulating valve.
Yeah, me neither.
But so, let's take maybe the constant flow regulating valve before. In refrigeration, there is if you talk about pressure regulation, for instance, evaporation pressure control, then you should place a constant pressure valve in that line to control the evaporation pressure. But actually, what it does, it's a regulating valve, so it's proportional. It has a proportional band, and while changing the load to the evaporator and changing the outlet pressure towards compressor, also the opening degree of the valve will change, and by that, finally, the value the valve actually is regulating at. So in many cases, this naming or this saying a constant regulating valve does a little bit misleading. If you size it in a good way, then it looks as if it is regulating very constant. Yeah, but it's usually it's a mechanical valve, I assume, and then you always have a proportional band, and then it depends how you size the valve against the required condition.
Yep, agree, Norbert. I'm a little stuck also regarding the double regulating valve, but Mohammed, if you can expand on the question, give us a application where you would fit such a valve and the job of that valve, then we can come back and we can take that a little bit later. So if you can do that, Mohammed, that would be brilliant. So we have another question coming up from Ephraim, and it says, does the Coolselector have SMS assist for notifications, mobile and remote control purposes? And I'll let you answer that, Norbert.
This is an interesting aspect. Unfortunately, no, we don't have that now. But yeah, there are many possibilities we can have. So as it links today to our online shop and availability of components, you get an information about news, you get an online version of Coolselector. We could also think of notification on mobile or remote control purposes. But this I would like to understand a little bit better in which context this is. So Coolselector as such is a selection tool, calculation selection tool, but it does not support remote control for a controller or for systems. But maybe this is a misunderstanding on my side. If you could, Ephraim, maybe elaborate a little bit on that.
Yep. Okay. That was an interesting question, actually, Norbert. It's how we, the world is becoming much more digital. So, yeah, how can we digitalize Coolselector a little bit more? To the best of my understanding, Norbert, we have Coolselector. As you say, it's a selection tool. It's PC-based software. It's not available for the mobile phone, but we do have many apps for the mobile phone to assist you on site. Yeah. So maybe we can get our adjudicator to put a link in the chat for that. Okay, so next question has come up. And there we have, at transcritical calculation field, you have a choice for optimal gas cooler pressure. What is that based on?
Okay, that's an interesting one. Let me share Coolselector so I can show you. If you go to calculate a valve for transcritical CO2 application, let's say like a transcritical high pressure valve, you get to the dialog where you get the input, all the inputs for the running condition of this setup. And here for the gas cooler, there is by default put in a tick mark for optimal gas cooler pressure. What does that mean? A CO2 system, especially on the high pressure side, it gives a high impact to the efficiency of the CO2 system. So if you do something not that good on the high pressure side, you can run into into low efficiency, a very low efficiency of the system, or even you can come into a situation where you get a shortcut of the gas loop. You get almost nothing out of the system. So to guide here with a value, we provide a calculation behind of this that supports in, maybe I can show you here. I just pick up a valve, go to performance details, and here in performance details, as you may have recognized, there is a detailed log pH diagram. Now the efficiency of the system, as mentioned, depends on where you are here in the top part, in the transcritical area. And this optimal pressure follows a calculation that is related on the ambient, on the gas cooler temperature, and the outlet of the gas cooler and the inlet of the gas cooler. So, and it follows an optimum value here along the lines up there. So it's not just increasing the pressure, then you come into a problem that the efficiency drops down, but it goes, it's more like coming from here, goes up here like this, as I show with a cursor. So somehow in that direction, we found out in many tests is the optimum performance of a transcritical CO2 system. So, and this you can get the value for just by putting in this tick mark. But you can remove and put your own values if you need different ones.
Okay, thanks, Norbert. That's yeah, a good detailed question regarding CO2. So another question that's come into the system, and is it possible to add a system parameter to the log pH diagram that we have in Coolselector?
We have integrated that function, as you may have recognized here, with a detailed log pH. The values you typed into the system condition will be added here, and the system is drawn automatically. In parallel to that,
you just need to share your screen, Norbert, a second.
Huh?
That's
sorry.
Okay. Good.
Yeah. Once again, here going to the detailed, all the input values are taken over, and the diagram, the system is drawn in as your condition you put in. This is done automatically. You cannot manipulate the values here inside this log pH on your own. It's going via the input fields. There is another way to go for log pH, that is going to tools, log pH diagram, and there you can pick up any refrigerant to get a log pH. And here in this area, we discussed already to enable in future to type in values and to draw your own system in here. This is not done yet, but it is on our list.
Okay, thanks, Norbert. That's interesting to know for me also. Very good. So I hope that answers the question to Alexander. We have another question come up, which, and I think this is a little bit of misunderstanding maybe, Babaya, but if the components of Coolselector are automated, how to ensure communication between the components and a central controller. As Norbert has said, Coolselector is the selection tool for the Danfoss components. If we're then talking about communication between components, and generally we're then talking about electronic controllers, electronic valves, etc., then that would be a totally different system. That's not Coolselector. That would be a front-end system controller type of device. So that's a little separate to what we're talking about today. So don't know whether you want to add anything to that, Norbert?
Yeah.
Nope. Okay.
No, I have nothing. No.
Okay, that's fine. All right. We then have a question come in from Mahendra, and it says how to select the orifice for expansion valve and what would be the ideal pressure drop across the valve.
Yeah, thanks for that question.
Yeah, that's an interesting one.
Yeah, definitely. I assume it's Mahendra is talking about thermostatic expansion valves, so I'll go to that one. Just share my screen with you. Here in the TXV area, the liquid line is automatically selected. I'll go to 134A refrigerant. I will put in a capacity of 8 kilowatt, let's say. I will keep the evaporation and condensation values as it is here. And go for a TU or TC valve in a selection. So this is the normal process to go through to get a selection done. However, there are a few points, and I think Mahendra is pointing to that one. Usually the evaporation temperature, talking a refrigeration system, is given. So this is fixed, but the condensation temperature may vary due to seasonal conditions. This is one variable value, and the other one is often underestimated, the distributor pressure drop. So if you have an evaporator with a distributor ahead of it, you need to consider a pressure drop across this distributor, which depending on the type size of the evaporator and the manufacturer, it may be somewhere between 0.8 and 2 bars, let's say. So let's put in a 1 bar pressure drop. So this will correct the pressure drop because it cannot utilized for the valve. It will impact the result. And another one is when it comes to summer and winter condition as the extremes. And this is my recommendation. If you go to select an TXV, always look at both scenarios, summer and winter. How to do that? You may have set up your system to run at a minimum condensation temperature of 25. And if you now want to check the summer condition, I would go for copy selection. This will do a one-to-one copy. And here I can now go to increase to, let's say, 50 degrees Celsius. And by that, I get a picture of what happens. So in the summer condition here, it would be a TC orifice 1 with a 74% load. And in winter condition, the temperature, and by that, the inlet pressure is much lower. But here we can see that it still fits. So this would be the choice in this case. So 89% is okay. As I mentioned in the beginning, that you should select this as close as possible to the 100%. Well, this is not totally the case here, but this is a good value, and as we can see, it will work in both conditions. So this would be my recommendation to select orifice.
Thanks, Norbert. Just to add a question onto that question, when we talk about pressure drop across, let's say TEV, so thermostatic expansion valve, what would be the minimum pressure drop across that valve to make it function, let's say? Just as a general rule of thumb, guide. for everybody.
Yeah. I know that there is always a question. Yeah, but you need to have a minimum pressure drop to get capacity through. Basically, if you have a pressure drop across the valve and it will expand after the valve, it can work. However, there is another aspect that is, for instance, if you have a too low value. Let me go back here.
Yeah, just share your screen again, Norbert.
Okay, thank you. And I would go down to plus 10 degree. And usually running such a low value, I also have a high subcooling value because of the totally oversized condenser under this condition. Let's say we have now here 10 or 15K subcooling. Then you can see we get a warning to all of the sizes, and the warning says here that at the outlet of the valve, the flash gas is below of a recommended minimum, and the recommended minimum with 5% is already quite low. So my recommendation would be to keep a pressure drop and subcooling or under these conditions to get a quality at the outlet of the valve of not below of 20%. If you come lower than that, it requires special evaporator design with inner fins at the inlet and so on to ensure that it will still work. So it's not that much a question of the valve as such, but what comes out of the valve and how can the system then handle that? Is the evaporator able to evaporate this? You will get a delay of evaporation of the liquid and so on. So there are many aspects, general aspects.
Okay, thanks, Norbert. That's good, just to elaborate on that one. So we have a question come up from Hassan. And the question is, I want to compare refrigerants. Is that possible?
That is possible, yes. That is possible in a way that you can either do a calculation as
just share your screen, Norbert. Sorry.
Yeah, thanks.
Okay.
Just do a calculation like we did here. Let me correct these values to a more convenient one. Yes, and here I have, for instance, refrigerant 134A. The capacities, I will do again a copy of the selection. But instead of changing the condition, I keep the condition and select another refrigerant, 513A, for instance, which will become a replacement or an alternative for 134A, and doing the calculation based on that one. So switching forth and back now between the two, I can see the difference. So here I get the same orifice, so that's already a good information, with the capacity of 8.65. And it was before using 134A 9.6. So the capacity is a little bit lower than before if I go to the new refrigerant. This is a one-to-one step approach, comparing one component to directly the same component with another refrigerant. What you can also do is going to the commercial applications. There is a part called retrofit tool, and this retrofit tool allows you to compare two different refrigerants for the whole system. So if I just keep the inputs here, R22 may be replaced by 47C at a normal temperature or intermediate temperature application. You can see that the change caused by the refrigerant properties are relatively small. There is only one indication showing the orangish color that is about the expansion device here. It should be checked to reset, but the pipes are okay. The compressor change is somehow to be double checked and so on. So with that tool, you can compare two refrigerants purely on its thermodynamic properties. So that you need to bear in mind. If you get a difference here for the compressor, for instance, doesn't mean necessarily you get the same difference if you compare two compressors which are optimized for the individual refrigerant. That could be different. Here in this tool, purely the properties of the refrigerant itself will be compared. Very generic.
Okay, thank you, Norbert. That's very good to know, the retrofit tool in these changing times of refrigerant.
Yeah.
Okay, so let's have a look at the next question. And so what takes the EEV or electronic expansion valve to fail on VRF units? Now, this is an interesting question. We had this in one of the previous live streams that I did with my friend and colleague Jörg Zar, and unfortunately it's a bit difficult to answer because we don't know why it failed. We don't know the failure mode of that particular machine. Also, we're talking VRF units. So I think we have to sort of leave that question, unfortunately, unless, Norbert, you have anything to add to that? No.
Difficult to say because there are many unknowns to come back with a relevant answer on this generic question. There are things like we discussed before. It depends on how the valve was sized, how the system conditions are changing, and all of that. How is it working in reverse mode? These are big unknowns here in this level of question. So it's hard to answer on that. It would require to go step by step through all these points to double check.
Yeah, I would agree, Norbert. I think one of the biggest things to say regarding any type of control valve is, if there's any dirt in the system, particularly you're talking very small orifices, that could be an issue. So that's always one that I sort of check. I found various strange things in valves over the years. I remember finding a plastic cap from a sight glass stuck inside a electronic expansion valve some years ago. I've found stones inside systems. Yeah, very strange things. But so yeah, let's leave that one. Now, another question has come in from Moreau, which is a little bit long to put on the screen, so I'm going to read this one out. And he basically is asking, when we calculate a cold room to cool beer and inform the software of a temperature of minus 1.5 degrees C, the software calculates a very high thermal load of the product due to the misunderstanding that it's going to freeze as we're below 1.5. But some beers have a freezing point below that. So we don't actually have that thermal load of freezing the product. It's still going to remain a liquid. I can sort of take that a little bit, Norbert, to say that the cold room selection tool that we have in Coolselector is a generic, fairly basic tool to calculate the base load of a cold room. If you need to calculate the load for something that is very special, and this one is obviously you know, a little bit special, then you would have to go back to first principles and do the calculation, not within Coolselector, but within a proprietary cold room selection process, or first principles, you know, longhand, using pen, paper, and calculator. I don't know, Norbert, whether you would like to add anything to that regarding the cold room selection tool in Coolselector.
No, it's exactly as you said. It's a generic tool referring to standard values. And yes, there are beers out there having different level of alcohol, which makes the freezing point differently. But it's hard to refer to those. But we got some discussions already talking about a possibility to maybe let user add their own products to be stored in a cold room. So to make it customizable, that could be a way. So we discussed on that already, but yeah.
Yeah, that's always a good topic, Norbert, and it's nice to hear that we're thinking about the to make it a customized selection. That would be quite useful. Okay, so always nice to talk about beer and wine, obviously. Another question that's come in from Rick Keating, and he says, "Is it possible to send the selection to my wholesaler?" And I guess by that, Rick, you mean from Coolselector. So Norbert, over to you.
Yes, this is possible actually to do that. While selecting a component, you can save that one and can send it directly out of Coolselector via email to your partner, if it is a wholesaler, your customer, or whoever else. The file will be forwarded, the same one as if you store a project on your machine, and you can handle it like you do with other Office files like Word, Excel, and so on, and just send them. And yeah, so this is possible. And by the way, interesting, while having here so many people from around the world, there are so many different languages spoken and unit sets used. You don't need to think of that if you forward a project file from Coolselector to another person, because Coolselector just loads the language on the receiver's PC used, and the unit set and everything. So by that, there is a kind of auto translation integrated. So that's, I think it's a good feature.
That's incredibly interesting, Norbert. I wasn't aware of that feature. So yeah, very good. I'm very impressed. That's yeah, very good. Okay, so we have some more questions coming in, and as we sort of thrive on questions when we're doing live streams like this. So more questions we get, the more answers we can give. So if there's any more questions, we would be really like to hear them. Now, one question that's come up is from Rick. Sorry, no, not Rick. Aldo. He says, "Can I add refrigerants to the software?"
Indirectly, yes, that's possible. But let me show you. So I have to share. Yep. And the way how you can do that, basically, Coolselector, while installing as it comes, will have a standard refrigerant library called ASAREP, provided by ASACOM Association. And this is for free and can distribute it by us. This is no problem. If you need to calculate a refrigerant that is not available in that list, you can go to Preferences, Edit Preferences, go to the dialog here, and to the last tab, Refrigerant Equations. Here you will find the information that actually ASACOM refrigerant equations are used. This is included. But if you have installed RefProp from NIST on your machine, you can select that one. But this is not for free. You need to buy that one. But if you have that, you can activate, and it points to the default path, or you can edit it, and get then also all these fancy refrigerants available. I call it here, let's say, RefProp.
Just as a question, Norbert, how many refrigerant choices do we have in Coolselector 2 at the moment? The default ones from Azicom. It's a fair few.
I haven't counted yet, but I think we talk about 50 or
yeah, so we cover the majority. Yeah.
Yes. So it's rarely happens that there is a need for RefProp. And by the way, RefProp calculates much slower than ASRep, so be careful with that one. It will slow down in some areas the calculation. But let me.
Sorry, Norbert, share here. That's it. Hold on.
Yep. You can see the list is very, very long. Yeah. So this now is coming from RefProp, and and this way you can expand and add, and as some may know, you can also define your own mixture in RefProp, so you are totally flexible. The only thing, the downside is you need to buy that on your own.
Okay. And where do you buy that from, Norbert? I know that's a strange question.
Get it. If you search for NIST on your browser, then you can you get results where it says also the address, and there you can search for RefProp, and you can get it from there. You can directly order via the NIST page.
Okay, that's good to know. Okay, so Norbert, I think you had some general topics to talk about today regarding the updates within Coolselector 2. So maybe we should jump to that for the moment and just take a break for the questions.
Yeah. Okay. Then let's go for that one. We got some new stuff in Coolselector. That is, for instance, for control valves, you will find the main valve, the pilot controlled one, ICS type. This is a parts program valve, since you need to order the valve housing and the required pilots. You will find now, going to code number selection, icon for pilot valves. So if you go there, you can open up and you get all possible pilots listed, and you can pick up from there. You can have multiple choices, as you can have multiple functions for one valve. So you can put one pilot, or you can put up to 3 or even more, depending on how you combine that with an external housing then. So this you can add here. Let me just add one at this stage, and after that it will be on the list of bill of materials. If you go to that one, you can see that the ICS 100 and the one pilot I just selected appears here on the list. There is another new feature while installing this latest version 4.6. You will find that in industrial part, the CSV file, the CHV valves, and the see the check valves. The check valves are divided now, the CHV in straight and angle way version. This is because the performance curves, the behavior is slightly different. So we decided to split them up to have here a more closer result to the final truth. Also, we have added for industrial to select an air purger. Those of you working in industrial refrigeration know that you will get a collection of gases, unwanted gases in the system and water. And by connecting this unit to the refrigeration system at different places, depending on the size of the system, it will open up the pipe automatically and release the gases and condense the condensable liquids. So it simplifies a lot to maintain the industrial systems. Safety valves, we got an improvement going to safety relief valves. There is an issue when it comes to CO2 applications, because CO2 reacts quite differently compared to standard refrigerants. One is that it becomes solid at ambient pressure or even above ambient pressure. And then also it has a high difference between density of liquid and vapor. And this need to be taken into account while selecting a safety relief valve for such a system. So if you add a pipe to the outlet, let's say these are 10 meters length, and you don't have a set point of 15 bar, but you may have one of 60 bars here in this case. Then one thing what will happen is a new type, an SFA 10H for CO2 application, high pressure application appears, but also a detailed calculation and a warning, if necessary, about the velocity and pressure levels in that outlet pipe. Having this information, it enables you to change the diameter to a larger one to get rid of these issues. You can see here, now you get an okay result. So, and by that you're on the safe side and you don't run into a problem that the outlet tube will be sticking with frozen CO2. At the commercial side, we have added a quality warning. I showed you already while talking about a minimum pressure drop across an expansion valve. So you should have a minimum quality or vapor ratio at the outlet. Talking efficient efficient and economic system design. It comes also to the charge of a system. As you may have seen, we have charge calculation already with the pipes when doing pipe calculation, and here we added the charge calculation also to the filter dryers, as they have a kind of a bigger volume compared to the tubes. So you can get the information from here as well. Some support while sorting the DCR with the replaceable inserts here, where we have different number of cores and connection sizes. And to guide here a little bit better through, we have added that one and improved by that the sorting of these kind of filter dryers. Coming to the cold room, we got an improvement there. That way to have now also electronic expansion valves available if you haven't seen yet. So if you go for the, let me just run through. At this point, at a step 4, until now, we only had the mechanical valves. Now you will find the electronic valves here available, and against for the control and sensor part of it, also all the parts, the items you may need. However, it allows also to specify in detail if you need that one or not, and to have here the complete package finally. If you are located in North America, then there is a new possibility to get also, let me go the next step, to get an evaporator selected. Here in this part, in this step, you can see this is the calculated load from the system, and the operating conditions. This will be taken automatically to get a sizing of an evaporator here. Going the next step, you don't need to do anything more than staying patient for a second. And here we are, the condensing unit, the controller, the liquid line with the different components, as well as the evaporator and the suction line will be selected for you. So, and from here you can process as you like, to go to edit a selection in detail or going to resize the cold room. There was a wish to have for compressors a possibility to have also the customized polynomials to export those. This is now part of Coolselector as well. You will get those for the selected compressor when you go to report. And let me just remove the not needed for this one here. Update. So I have only the compressor. And if I open the dialog here, you can see code number is default and the compressor type, but then you can define what else shall be part of the report, as well as the standard condition polynomials, or the polynomials based on your input conditions. Well, beside of that, there are some general improvements. One is we have added, beginning in the first quarter this year, a new ASAREP library, which has been improved and expanded also refrigerants we can provide to you. Then we have added a notes field where you, while doing a project, you can just add a note on your own to remember something or to give an additional information, and this will be saved with the project when you save it on your machine. Well, a very great feature, and I sure you will enjoy that one, is the free search. So if you get a code number and you want to know which component that is, you just need to type in what you have. if I go here, I get a thermostatic expansion valve and with a code number. So you can type in the code number you have, or you can type in the component information you have. So it's a free text field, and it will search for everything that that goes into that direction. And by that, you can find very fast components, code numbers, or whatever you are looking for. And while finding, for instance, an EVR6 valve, I press Enter. It opens up a calculation dialog, taking over your last condition you typed in and provides you with a performance calculated. So if you know what you have and you want to know the capacity, the performance of this, just put it in, press Enter, and you have it.
That is...
I think that's for the day-to-day work could be quite helpful.
Yeah, I think that's incredibly useful, Norbert, to be honest, be able to search not only on code number, but even on EVR, you know, any of the generic sort of model references that we use within Danfoss.
Yes.
We tend to be quite code number orientated, but also EVR, for example, for solenoid valve. So yeah, I think that's quite useful.
Exactly. And if you see that in combination with the already provided possibility to get all kind of documents here from the information tab, go to documents, visuals, you get a direct access to those informations related to the selected component. Or like here in this case for a compressor, you can export a data summary for the selected compressor. You get a whole bunch of information of the summary, the technical data, the accessories available, and so on. And you can just add it to your documentation of your project.
Perfect. Okay, we have...
That's in a quick run news in Coolselector we did during the past month. So we had some points here.
Thank you, Norbert. Very good. Yeah, I like some of those. I'll certainly use those in my day-to-day use of Coolselector. We have one question from Mohammed that has come up. And I think, Mohammed, what you mean by that question, in direct expansion split systems, what adverse effect will it be if the suction? Now, I think you mean suction and liquid and not discharge lines are run within the same insulation. I don't know why you would run your discharge line with your suction, so I presume you mean liquid. So I guess that's the question. And Norbert, over to you again.
Yeah, thank you. That's a very special one. That's a very special one, actually. There are different approaches to get the right superheat value out of a system. And we need to distinguish clearly between a refrigeration-like system, if it's a chiller or a refrigeration or a freezer, whatever. Everything what goes into this area, you can calculate using a so-called superheat ratio. So there is a relation between the inlet temperature and the evaporation temperature that allows you to go to a certain superheat value that your expansion device adjusts. So this is about 0.65. It can be a little bit more, a little bit less, depending on the design of the evaporator. This is one thing. And for that purpose, we also provide our Superheat Tuner app for your mobile device. You can use there. What you can't use that one for, actually, is what you asked for. It's for air conditioning systems. There I learned that there is a totally different approach that brings the ambient temperature, the wet bulb temperature, evaporation temperature, and so into consideration of that. And depending on this temperature relation, you get to a point that under these circumstances, the superheat value of this little is possible. Under different circumstances, superheat value of that much is required to protect the compressor against leakage. So this is quite different, and there is no one value like the superheat ratio I can give you for this air conditioning system setup. This depends on the ambient condition the system actually is running at.
Thanks, Norbert. Yeah, I guess that's quite an interesting question, and I see that quite a bit on my travels. With air conditioning system, it's fairly standard because generally the liquid is expanded at the condensing unit rather than the evaporator. So, generally you insulate both lines. But I also see that on my travels where they've put the suction and liquid together in the same insulation to avoid, solar gains in, much hotter countries where I'm based than the UK, so to speak. We have one more question that I can see coming in on the chat, and the question basically says, and it's from David. It says, why does compressor burn? I presume. What is the cause? That's quite an involved question, and it depends whether we're talking about a burnout of the compressor or whether we're talking about high discharge temperatures, so we burn the internals of the machine. Norbert, I don't know whether you want to take that, or I can
go ahead. This is
continue just rambling.
Yeah.
My favorite topic. If we're talking about why do we burn a compressor, and if we talk about one of the biggest issues we have with compressors is high discharge temperature. If we have a high discharge temperature, then we can cause issues with the mechanics of the compressor itself. We also carbonize the oil, so the oil doesn't lubricate the bearings, so basically the compressor fails. The biggest cause of that is having a high suction superheat back to your machine. And by that, if we have a high suction superheat, we will increase the discharge temperature exponentially and cause failure. So if we're evaporating, let's say at -20, we want something back at the machine, ideally below 0 degrees C, hopefully a little bit more so we keep the compressor cool. If we run a high discharge temperature and a high suction superheat, then we will, fairly quickly kill our machine. So you need to measure the suction superheat on your machine. Normally in the evaporator, we'd be running, between, let's say, 8 Kelvin superheat, and then another, let's say, 5 or 6 on top of that coming back down the suction line. We keep the machine nice and cold. If we've got, let's say, 20 Kelvin superheat, not too bad, but basically want to keep that machine as cool as possible. So check the suction superheat on your machine really is the main one, and obviously make sure the condenser is clean, lots of airflow, enough refrigerant in the system. There's lots of sort of points we could go on and on. There is some webinars that I've done in the past regarding compressor failure, which are available on YouTube, so that's always a place to look as well. Okay, so a question has come in from Moreau, and again, this is quite a difficult question actually. Is it financially viable to replace and I presume you mean TV, with an electronic expansion valve in a low capacity equipment? The simple answer, I guess, would be no. It's not financially viable because obviously with an electronic expansion valve, you have the controller, you have the sensors, etc. It all depends really on the application and exactly what you're trying to do. If you want to maintain a very, very tight, stable superheat, then EV is one option. There is some discussion, and we had a live stream head-to-head a few weeks ago with a colleague of mine where we talk about the thermostatic expansion valve versus the electronic expansion valve. And really it all comes down to the application. If you have a TEV, a thermostatic expansion valve that is set up correctly, it is almost as good as an EV that is set up correctly. It all depends on the application, the maximum duty, the minimum duty that you want to have in that application. So a little bit of a difficult question to answer, but if we talk about the financial viability of it, it all depends on the application and what you're trying to achieve. Norbert, anything to add to that one?
No, fully agree on that. So there is no general saying that in this case always an EEV is better than a thermostatic valve. I fully agree on that.
Okay, thank you very much. So I think we have come to the end of the questions. Norbert has covered all the points that he wanted to cover regarding the update of Coolselector. So I think we are sort of done. I'd like to say a huge thank you to Norbert for his expertise in working the screens and working with Coolselector. And if you have, let's say, topics for live streams that you would like us to do in the future, we'd really welcome those comments in the chat. And if that's everything, then thank you very much for tuning in and taking part, and we'll see you all again soon. Thank you.
Thank you. Have a great rest of the day and talk to you soon, hopefully.